All right, and welcome everybody to the Daily Space Weather. This one was originally streamed live to twitch.tv/smAsho. Doing things a little bit differently today, going back to our roots when we used to stream regularly. We did see some C-class flares. There was a coronal mass ejection just a few hours before we recorded the video, live streamed the video, whatever you want to call it. Here's the last day of the sun in 171 angstroms. And let's talk briefly about the coronal mass ejection. It came from down here. You can see a little prominence from there. We'll show you the likely trajectory of that CME shortly. First, let's look at the sunspots. Decent sized group in the southern hemisphere, decent sized group in the northern hemisphere. They've remained mostly stable. A new group has formed over here as well. There were as many as 6 sunspot groups in the past day or two. We'll look at a further analysis of that. Let's take a look at the viewpoint from Lagrange point 5, where stereo A is located, this pane here on the left. And you can see this little CME emerging there. It's some old data. Looking at the viewpoint from Lagrange point 1, we see the LASCO C2 and C3 showing us that the coronal mass ejection is minor and headed off well to the west and a bit to the south of the Earth. You can see right out here a little bit of plasma ejection out of the solar corona. Coronal mass ejection watch stays in effect, folks. Solar flare watch stays in effect as well. Here's a composite image. This is ionized helium and iron, 304 and 171 angstroms. It's more imagery from the Solar Dynamics Observatory. We've got some more close-up spectacular imagery for you toward the end of the video. Here's 94 angstroms as well. Again, coronal mass ejection watch and solar flare watch remain in effect. And the radio flux has dropped down to 78. Let me just check the life of the stream here. And everything looks just fine. So 88 solar flux units is the now 10.7 centimeter radio flux number. Approaching 90 here. That graph is from Solon.info. The black line is the radio flux. The red line is the sunspot number. You can see NOAA has forecasted a geomagnetic storm early in the day tomorrow, Monday, September 27th, and a geomagnetic unrest period. A minor geomagnetic storm, rather, a geomagnetic unrest and geomagnetic storm late today on the 26th. And it's, quote, due to interaction from a positive polarity coronal hole high-speed stream coupled with possible transient activity from the 23 September CMEs. Those weren't Earth-directed CMEs, folks. I don't know what they're talking about. But anyway, that's NOAA's forecast. Let's look at volcanodiscovery.com's bar graph briefly here. That's the past 90 days at a glance in terms of earthquake activity. There has been a little bit of an uptick here, although no major quakes over the past 24 hours. There was a deep quake at the Bande Sea, north of Australia. A 4.8 north of New Zealand. A 5.3 at extreme depth, 638 kilometers there. Looks like it's south of Fiji. There was one west of Greenland also there. A deep quake in western South America there, a 4.8 magnitude. At Argentina, estimated 211 kilometers depth on that one. Iran saw a 4.5. Some quakes striking Hawaii, as well as the Reykjanes Ridge, southwest of Iceland. South Sandwich Island saw a 5.4. That was one of the largest quakes of the past 24 hours. Some quakes in the Caribbean, like this 4.1 at the Dominican Republic at over 100 kilometers depth. About 40 minutes later, a deep quake there at Peru. So minor uptick in earthquakes here. Again, no major quakes over the past 24. Checking volcanoes from volcanodiscovery.com's Volcanoes Today page. La Palma continues to erupt on the Canary Islands. 5,000-foot ash plume from La Palma, Karimsky. 17,000-foot ash plume produced over the Kamchatka Peninsula as Karimsky explodes. Sakurajima, south of there, near Kyushu, Japan. On the Isle of Kyushu, Japan, rather. Flight level 080. It's producing an 8,000-foot plume of volcanic ash. Subanosejima, 10,000-foot ash plume over the Ryukyu Islands. Simisa Pochnoi in the Aleutians, volcanic ash report not provided. Nevado del Ruiz, 19,000-foot ash plume as it explodes. That's located in Colombia. Revenador exploding, 15,000-foot ash plume over Ecuador. And Sabancaya, 24,000-foot ash plume over Peru as it explodes. If you're going through hell, keep going. And no matter how bad things get, do not pole vault the caldera. It could be unhealthful. Although if you do need to pick up some gear, head to smashomash.com and click on smAsho merch. This will be one of the many choices in the offing. Don't get off-ed. Join the Smash team. Pick up some merch. Head to smashomash.com. Press like, subscribe, tell your friends and foes about the channel. Smashomash.com/Smash team, the new source of funding. Happy Smash-tember. Thanks to all of our Smash team members. Next, going to the GOES magnetometers here on the GOES 16 and 17. Earth has entered a North Pole current sheet, which was probably happening around this time when you see these rather wild swings. But in any case, let's take a look at the global oscillation network known as the Gong 2 data. It's the top view ecliptic plane field plot looking at the polarity of the heliospheric current sheet. And you can see in the last image here, Earth is now in a North Pole current sheet shown here in green. South Pole current sheet now in Earth's past as it continues to rotate around with the sun. You can see this blue line coming way down to the south, allowing the polarization of the North Pole, the North Solar Polar Field, to polarize the plasma. Here's the line of sight coronal hole plot, and you can see another coronal hole forming here in the east. Shown there in red, it's a South Pole oriented coronal hole. And here's a visualization of that. The last 24 hours, 193 angstroms from the Solar Dynamics Observatory. You can see a little bit of darkening over here, a lot of darkening up here. The North Solar Polar Field is currently in charge of the current sheet. Next, the flare monitor and detected sunspot groups. You can see we got all the way up to 8 groups here for a moment. Although those aren't named, this detects them nearly immediately. The solar flare probability monitor is on the first page of the Integrated Space Weather Analysis Center. The most interesting area is still sunspot 2871. It's still beta gamma class. That's why we still have a solar flare and coronal mass ejection warning in place. Actually, the solar flare warning. Coronal mass ejection warning is completely different set of variables that I can't describe in the daily space weather. And here you can see the solar flaring activity over the past 3 days. Quite a few C-class flares. 6 C-class flares over the past 3 days. No spikes in the proton flux there. No relativistic particles have been sent our way. Now let's go to the real-time solar wind next. And the coronal hole wind stream has largely subsided here. So current solar wind velocity, 425 kilometers per second. Solar wind density, only 3.6 protons per cubic centimeter. The rest of the solar wind data there, rather unremarkable. The KP index, a measurement of global geomagnetism, at 0, a KP 0 for the past 6 hours, each bar representing 3 hours. And let's take a look at the geospace here. It's 4 hours of the space weather modeling framework, which uses a bunch of variables to model magnetohydrodynamic pressure, which is expressed in nanopascals. It's 4 hours of data courtesy University of Michigan. We show it daily on the daily space weather videos. geospace magnetosphere movies. Homogeneous, unremarkable, low pressure over the past 4 hours. Next, ground magnetic perturbations, geospace delta B, our other geospace magnetosphere movie. Not a lot of major changes going on with Earth's magnetic field. Geospace delta B changes to Earth's magnetic field. It's a slow, steady, and diffuse coronal hole, solar wind, rather. Next, the diagram of the solar system. Here's where stuff is. If you're wondering where stuff will be in a week, there's where it'll be on October 3rd. The third day of Smashtober, which will be completely different than Smashtember. Once again, happy Smashtember to all of our viewers. Next, a star chart here. Mine's facing to the south. I'm currently facing the south. The moon is up there on the ecliptic, which is the yellow line, the path the sun will take across the sky. Let's continue on to do a brief cosmology segment. If you didn't see yesterday's, it was quite spectacular. The last two cosmology segments that we've separated out of the Daily Space Weather videos were quite good. Check out the playlist at youtube.com/smashamash/playlists. The astronomy picture of the day is the Red Square Nebula, quite famous and widely speculated on as to how a round star can produce a square nebula. So perhaps it's giving us some insight into some unknown astrophysics. But the Red Square Nebula is pretty important. It's known as MWC 922. And this image here is a combination of infrared images. It's the astronomy picture of the day, apod.nasa.gov. Now, we regularly pick random numbers, and we coincide them with an object at the Neil Gehrels Swift Observatory. If you go to this home page and you click on BAT transient light curves, that will show you this page. If you pick an object, let's pick the massive radio source at the core of the Milky Way galaxy, Sagittarius A star, and you click on that link, it'll show you the hard X-rays from Sagittarius A star. If you click on Simbad, you'll end up on this page, and of course, Simbad's not going to find Sagittarius A star. It calls it something else. Let's pick a different object here. I haven't looked at Cygnus X3 for a while, so let's take a look at Cygnus X3, otherwise known as Deneb's little friend. And there is Cygnus X3, one of the only known cosmic ray point sources. So if you click on Simbad, you'll have this link right here to the CDS portal. And if you click on that, you'll go to the CDS portal, which will look like this. And we've done a search here to find MWC 922. So this spectra right here, this is 8.28 nanometers, part of the infrared spectra. And you can see the Milky Way plane there. We're going to zoom in on MWC 922. And you can see it is a bit boxy shaped there. Let's take a look at it in some other wavelengths. And it does indeed show up on the pan-stars. And you can see that distinctive square shape even in optical wavelengths. Quite an interesting nebula and system there. Nebular cloud, strange boxy shaped scenario going on. I don't think it shows up on the XMM Newton, but let's take a look anyway. And indeed, it doesn't. And let's just go back to infrared here. Let's see if it shows up on the 2MASS. Let's look at CDS featured. And there's the 2MASS. The boxy-shaped MWC 922, folks. Another great thing about the CDS portal is that it shows you the spectral data. You can see it's much brighter around 1 nanometer than most of the rest of the spectral data. Again, if you want to see how to get to the CDS portal, Just go to Neil Gehrels' Swift-Bat X-ray Observatory right here. Click on Transient Light Curves. Find your favorite object. Mine's Cygnus X3. Click on SIMBAD. And that will allow you to go to the CDS portal. You can look up more of your favorite objects in all kinds of wavelengths. It's just spectacular. That's today's Cosmology segment. Let's get back to some more space weather data. First, allow me to make sure that the stream is still copacetic and everything looks fine. All right, so charging hazards are non-existent around planet Earth right now. We'll move on. Here's the relativistic electron flux over the past year reported by Solon.info. Here's the 3-day greater than or equal to 2 mega electron volt electron flux. Pretty unremarkable there, just moderate levels as the coronal hole wind stream has largely subsided. Here's the forecast. I would tend to agree with an uptick forecast here. The green boxes are the forecast. The yellow diamonds are the observation. And here's a diagram of Earth's Van Allen belts. We're going to show you the total electron content forecast next, which gives you ideas of where GPS errors are most likely to occur, and also chaos in Earth's magnetic field if that's going on. It's not going on. Things are looking pretty normal and organized here in the total electron content forecast. Next, the Ionosphere Layer, located at about 300 kilometers of altitude. Here's your ionogram. We show this one daily as well. It's just one slice of the atmosphere in vibrational frequency. In many ways, it's the bridge between Earth and space. There's a lot of chemical reactions going on in there. This is also the point in the atmosphere where the GOES 16 and 17 are measuring the electron flux. While they're in a geosynchronous orbit, they're using radiography to measure the electron flux at 300 kilometers of altitude. Geosynchronous orbits are more like 12,000 miles of altitude. And we're seeing lots of high-frequency anomalies here. There's the latest image, 10:45 Universal Time. Here's the anomaly map showing departure from the 30-day median in megahertz. Also some low-frequency anomalies over West Africa, the Northern Atlantic Ocean, North America, the Caribbean, shown in red. Right around these areas, some low-frequency anomalies pushing in. Or you could say pulling out, depending on which perspective. Are you looking at it from space or from Earth? Anyway, there's a latest image on the anomaly map, 10:45 Universal Time. Not looking all that abnormal at the moment. Today's meteorology segment is going to be integrated into the daily space weather video as well. We'll keep it rather short. We're looking at sea surface temperature anomalies here. We've got quite a bit of cold water and some hot water here in the Pacific Ocean. Anyway, let's just look at the surface winds. And we do have a cyclone. We're getting some alerts, some of which we recently shared with the SMASH team at smashomash.com/SMASH team. Anyway, there's the surface wind scenario for the eastern world. Here are the jet streams of the east. Some backward jet stream here once again over the western Pacific. Here are the jet streams over the western world. And cold air being sent my way once again from the Great Lakes. Some Great Lakes air headed my way. We're located in Lehigh Valley, Pennsylvania, by the way, folks. Here are the surface winds of the western world. Tropical system here east of the Caribbean. Here's your weather.gov map. Some flood warnings there. Flood advisories in Maine. If your county is lit up, please click on it. It's weather.gov. Weather.gov. And here's your lightning mapper. Got some lightning in Arizona and New Mexico in the past 8 hours. Here's a real-time lightning map, courtesy lightningmaps.org, powered by blitzortung.org. It's good times. And we've got some lightning here in south-central Europe, northern Italy, and so on. No terrestrial lightning in the U.S. at the moment. Let's move on. To look at pressure cells, we'll advance this into tomorrow. First, I would note that the entire Antarctican region is entirely encased in low pressure. The South Pole, completely dominated by low pressure. Anyway, here's the European forecast for pressure tomorrow. That's where the European forecast Plots pressure at 1300 Eastern Daylight Time, 1 p.m. Eastern Daylight Time. Next, your NexRad satellite. Your NexLab satellite and radar, I should say. This is a simple water vapor map. Continuing on here to look at the Pacific Ocean in terms of cloud cover. So there's the cloud cover over the Pacific. That system south of Alaska now moving into British Columbia. Here's your Doppler radar map. And we'll zoom in on the lower 48 here. You can see some heavy rains across Maine. And it's going to start raining on the northern peninsula of Michigan. That will eventually move over to Lake Erie and Lake Ontario. Looks like some much needed rain falling in Arizona and New Mexico. Thank goodness for that. Next, the cloud layer over the lower 48. There's what's going on there. Here's the water vapor map. And you can see this jet stream trend pushing some cold air into the mid-Atlantic states. I think it's going to be an epic year for snow in the Boston, Washington, D.C. corridor. What do you think? Let us know in the comments what you think about that. If you've been checking out the rest of our meteorology segments, congratulations on realizing our channel exists. This video appeared on BitChute and YouTube and was originally streamed to twitch.tv/smAshomash. And that's today's meteorology segment. I've been your host, Dan, a.k.a. smAshomash, not signing off from the Smash News Network, least busted name in news, because we've got more space weather to deal with. And this was all integrated into one video. Doing something special today for Sunday. So thanks to our BitChute subscribers. To our YouTube subscribers, I would note that we're seeing, 800 views per day, 1,000, 1,100 views per day on our BitChute videos, and only about 300 per day on YouTube, despite over 1 billion daily viewers on YouTube. I'm sure it's just a coincidence, folks. Sorry that the content sucks so hard that nobody wants to watch it on YouTube. Please tell your friends, foes, science noobs, and science pros about us. Again, this was originally streamed live to twitch.tv/smAshomash. Look for more videos coming to Twitch. It's the world's best live streaming platform. Thanks to our viewers on YouTube, etc. Wherever you're viewing, leave us a comment. Press share. Share in your social media. Otherwise, Mark Zuckerberg's Facebook page and Jack Dorsey's Twitter feed may not have our videos. Next, thanks to our patrons. Please cancel your Patreon before October 1st. We will stop posting there by October 1st. And we'll be posting everything to smashomash.com/smashteam. So here's a little tidbit into what our viewers get at smashomash.com/smashteam. There are 2 paid levels and an annual paid-up membership, which entitles you to complimentary merch. smashomash.com/smashteam. It's epic, and it is vastly superior to Patreon. So if you're new to the smashomash.com/smashteam page, just click posts, and you'll get this type of view. Again, it's just vastly superior to Patreon, and we love it. Thanks to Smash staff and our Smash team members. Welcome to the Neo Renaissance. Visit our homepage, click SMASHO merch. You'll find things like this. And I'm currently wearing some. And I would remind all of our viewers to Mensa and make Earth not suck again. Just like the hat says. It's up to you to make Earth not suck again, not giant heaving bureaucracies that can't even get out of their own way. Mensa, also Mansa, make America not suck again. And hold fraudsters accountable, folks. Never forget to demand accountability for people who commit fraud, the misrepresentation of material facts. There's the Mensa hat. I'm wearing one right now. Here come our bonus features. It's the latest from the El Teide ground-based solar observatory here in El Teide, Spain, in the Canary Islands, I might add. El Teide, the high point of Spain. That data is only 2 minutes and 37 seconds old. Some filaments, sunspots. Again, coronal mass ejection watch and solar flare watch remain in effect. Here's the latest intensity gram. We're going to press refresh. That sunspot's degraded, although there are quite a few umbrae spread around it. This sunspot has largely consolidated but not grown. It's been mostly stable. We've got some more active regions here. That is definitely a significant sunspot. Here's the colorized magnetogram to show you more likely areas. And you can see some possible new sunspot areas. Actually, that's a sunspot there also. It'll probably not get a name. It's only been there for a brief period. We won't conjecture on it. We'll just continue on. Here is the 304 angstroms one-day video from the SDO. You're going to see a prominence down here. Not a crown prominence. Those occur at the poles. And that was the source of that coronal mass ejection that occurred around 0300 Universal Time today on September 26th. And we'll close things out with a Northern Hemisphere composite and Southern Hemisphere composite. This is 131 and 94 angstroms. Which those are both ionized iron ultraviolet emission spectra. If you're wondering what you're looking at there, that's iron. And the white spots are the largest concentrations of those ionized states of iron. And here's the Southern Hemisphere where most activity is currently occurring. And thanks for tuning in to the Daily Space Weather. Once again, congratulations on realizing our channel exists, and may that solar wind be at your back.